Okay. Thank you guys for joining the Multifamily Builders Council presentation for September. I appreciate you guys hopping on. A quick announcement real quick is the multifamily golf tournament is still being held. It's going to be held Friday, October the 16th at the courses at Waters Creek. We still have a few sponsorships available. We're looking for about 8 additional sponsorships. So if you haven't gotten in, please sign up. $1,500 get you a team and a sponsorship for a hole. We will be following all the COVID-19 guidelines in place and want it to be as safe as possible for all the people participating. A couple quick reminders about this webinar. This webinar will be recorded and posted on the Dallas Builders Association YouTube channel and social media. And we'll also be taking questions at the end of the program. Please put any questions you have into the Q&A at the bottom of your screen, and then questions will be answered at the end of the program. I would like to welcome and thank Jordan Skala for putting this on for us. Erin Bordelon, James Brauer, and Ben Weissman are here to present. And so without much further ado, I'm going to turn it over to them. Thank you, guys.
Well, thank you, Ron, and welcome. I seem to be having a little bit of a hiccup with internet connection. So Erin or Ben, if you see any kind of lag or anything, please feel free to jump in or take control as appropriate. So again, thank you all for joining us. Today, we're going to talk to you about some energy code stuff, but first a little bit about who we are. Most people know us at Jordan and Skala as one of a premier design firm for the mechanical, electrical, and plumbing design. And we've historically had a very strong emphasis on multifamily design. What many people might not know about us is that we also have a full-scale low voltage design service, as well as our sustainability team. Just a brief overview, our sustainability team, we have structured such that we have 4 specialized groups for whatever your green building needs, energy modeling, or any of your field services, which is covers both residential or commercial energy code. So on our agenda today, we want to cover where we are now with the energy code, some of the trouble spots that we've been seeing from our inspection process, and then talk some about where we're going, and then touch upon some of the hot buttons of ventilation in regards to outdoor air, and identify some more information for you in regards to what we're seeing in relation to COVID. So first off, with North Texas, we have a variety of different codes that you might have to follow at the current point in time. For the state, we are 2015 IECC or higher, and we've had some municipalities that have chosen to do the 2018, more stringent. But with the commercial energy code, you could also choose as a compliance pathway the ASHRAE 90.1 standard. Whether that's the 2013 or the 2016. And on the screen here, we show kind of the direct correlation. As you see, the 2018 IECC can use the 90.1 2016 version, or 2015 uses the 2013 version of ASHRAE 90.1. As you notice, ASHRAE 90.1 always is 2 years less than the current IECC. Residential energy code does not have this variety. They have just the as written energy code. It's also important to note as we discuss things that for commercial energy code in relation to multifamily, that is going to be anything over 3 stories, and the residential energy code applies for anything 3 stories or less. So as mentioned, we have a number of municipalities that have adopted the 2018 IECC. Quite a decent handful on the screen here, with Levon just having adopted it, and Dallas will be adopting it soon. They had a direct date identified pre-COVID, but it's uncertain on if that's actually going to be adopted or if they're going to wait a little bit.
And James, I'm just gonna, sorry, to step back just a little bit, as James was saying, the 2018 code is being adopted throughout. This is just a sample of the cities, municipalities around DFW in the North Texas area that have adopted 2018 already. For example, Lavon, I just heard about that on Friday. I called the city of Lavon after looking online. They do not have anything posted yet, but they assured me that, well, it was adopted last week by the city council, and it is going to be enforced as of last week, and they'll get us more information. So I think this is a really good example of just how quickly things change, and as we move forward, SPEAR has a list of cities and municipalities that are adopting 2018. So again, feel free. Our contact information is in this presentation at the end. Feel free to email me. I can provide that list or a link to that list anytime.
Wonderful. Thank you, Erin. One of the other things that municipalities are allowed to do is they can certainly make some amendments on how they operate. I imagine that the majority of people on this call are probably familiar with the City of Dallas requirements, where you have to utilize a third-party provider that's been pre-approved by the City of Dallas for both your energy code and for your Dallas Green Ordinance compliance. This is both a permit check and then as well as inspections at the end with official affidavits sent to the City of Dallas before you can get your TCO and or CO. Denton requires a test each mentality, which is, when we say test each, this is directly in relation to the duct blaster and blower door testing that is required under the residential code. McKinney wants to have a designated commissioning agent that is identified at permit that will then also submit a form again for you to be able to receive your CO. The City of Frisco performs their own energy code inspections. They don't do the testing though. So you'll want to make sure that you have somebody that's qualified and signed on to do your testing for you if you fall under the residential code. They also ask for Energy Star shingles, or also known as cool roofs. The City of Allen has at times some interesting interpretations in regards to the code. And one example of this is for the fire inspection check. They will check for full fill insulation in your truss space with the camera. So the City of Allen can sometimes be interesting to navigate due to some of these interpretations. City of Benbrook has one inspector doing all their inspections. So they're a little bit overbooked and overloaded. So certainly some patience with our friends at Benbrook, or some planning ahead when you need an inspection. City of Fort Worth, in much the same way that the City of Dallas operates, they require third-party plan review and inspections, but they have a limited selection of pre-approved third-party inspectors. There's only 6 companies that are pre-approved that qualify, due to the fact that the City of Fort Worth will only accept you if you can do all the required inspections. So mechanical, framing, the whole ball of wax. Now, since this gets fed out from all those different inspections, each company can have a different interpretation of what the IECC requirements are with a bit of variety. Some of the common problem areas that we're currently seeing, some of the pain points that we see when we go out and do our inspections that would be good for you to know so that you can plan appropriately. The duct tightness testing is a good one to discuss. The North Central Texas COG amendments have been fairly favorable in that they have allowed sampling. The code as written does not allow you to do sampling. Sampling is the methodology in which, once the tester has a comfort level, you only have to check 1 in 7 or 1 in 5, depending on the different area or code that you're following. One thing that you'll want to check and be sure to avoid any uncased fur-down air handlers. These particular pancake units, since they are encapsulated with sheetrock, which can sometimes be difficult to seal appropriately, can make it very hard to pass a duct tightness test. A much better scenario is to use a cased fur down with a ducted return, so that it removes the sheetrock from the air distribution system. Another thing that you want to look at is both air sealing, where this is in both the commercial and the residential code, and in conjunction with the dwelling unit blower door test, which is only residential. Again, the North Central Texas COG amendments allow not only for sampling, but they also have a more favorable testing threshold. The code as written says that for 2015 says that you have to test to 3 air changes per hour at 50 pascals. Just a normalized threshold to identify, so regardless of the size, you have a clear testing threshold. The COG amendment allows you to do ACH 5 for a corner unit or 5.3 for an interior unit. This allows for a little bit of extra leakage since we know that there's going to be some leakage between units. So this allows a more favorable test for you. Another item to check and make sure on there in code is a requirement for the hot water pipe insulation and specific run lengths depending on what you're serving and how long of a run. The IECC as written says that from the point of heating source to your fixture, all the hot water pipe needs to be insulated. So this is a thing that, depending on your code official, might have extra stringency on to double check and make sure that that's being met, as well as the specific run lengths. Next, a very important thing that we see happen frequently is the knowledge that with the 2015 and higher, your buildings have to comply with commissioning. Commissioning of your mechanical systems, your water heating, and your lighting controls. And this is specifically only in the commercial energy code because that same type of commissioning mindset is what the duct tightness test and the blower door is all about. Within a multifamily unit, dwelling units are exempt, and your mechanical systems only have to be commissioned if you have 40 tons of cooling or higher. There's also a requirement or an exemption based on how much heating, but usually we find the more stringent litmus test is actually in regards to your cooling. And really the decision point is whether or not you have conditioned corridors in a 5-story wrap as opposed to unconditioned corridors with your standard 3-story garden style apartment. Now, lighting controls come into play in your amenity centers. Whether you have a detached clubhouse or you have your amenity center built within your 5-story wrap, both of those areas will be should be commissioned on your lighting controls. And this is in regards to your occupancy sensors, daylight sensors, and your time switch controllers. We also want to point out and discuss that there are some performance path trade-offs. This is specifically with a mindset that when you go to do your VE process and the understanding of what all is required, what was required on one job might not be required on another if, say, the first job was following the prescriptive path measures and project 2 is doing the performance path, which is an energy model. There's a number of prerequisite mandatory items that fall under the prescriptive measures that you don't have to do if you're doing an energy model. So if you see some of these things, it's good to be aware and identify whether or not the project was permitted as the prescriptive path or under the performance path. Next item to a new item that has popped up is in regards to your window air leakage. looking at the image on the screen, we're familiar with this window sticker. And traditionally, your energy code inspector or city inspector has largely looked at the U factor and the solar heat gain coefficient. Under code now, we're also going to be checking for this air leakage number. Within climate zone 3, we need to meet a 0.3 or less. We bring this up definitely to make sure that you're checking early and your submittals are identifying the air leakage, because you certainly wouldn't want to install a whole mess of windows and then have a very strict energy code inspector come out and because of your air leakage say that your windows aren't compliant. Also, we want to talk about ventilation as noted, but we'll save that discussion for a little bit later. So where are we headed? Big question on a lot of people's minds. We've taken a lot of huge steps in energy code throughout the years. This next section is going to be kind of our educated guess on where we see and what we think is going to happen within the next 10 years. So as mentioned, over time, the energy code has dropped very significantly in a number of sectors. The orange-yellow line, depending on how that's coming through on your screen, is the residential code, and the bluish line is your commercial. As you can see, the commercial code has dropped significantly at points and has taken a very kind of consistent downward turn, whereas the residential has, on a few key areas, made significant drops, but otherwise has stayed relatively the same. Key identifier, as you can see, is that with the 2015 ICC versus the 2018 versus 2012, there's been very little change. But when the state went from the 2009 code to the 2012, it was a very strong drop. What you're seeing on your screen now is the roadmap for ASHRAE 90.1. As mentioned, this is an alternative compliance pathway and runs very similar. It's the energy code standard that ASHRAE puts out from year to year. And you're seeing the roadmap through their ASHRAE 2031 version, where if you look at the end of the screen, they are still focused and pointing at reaching a net zero energy by 2031. And as you recall, the 2015 IECC follows kind of 2 years after endpoints. So when we discuss the 2031 code, we're talking also similarly probably in regards to the 2030 or the IECC 2033. Within here, sorry, go ahead.
Sorry, I was just going to say, as the energy code does get more stringent, that is where we are seeing discussions that would go to net zero. Not that it is for sure, these are all educated guesses, but you see the AIA 2030 challenge, net zero, lots of cities, carbon neutral goals that are going in about 10 years is kind of the target date. So that is what we see shortly thereafter is where the codes are going, energy code and the efficiency and stringency.
And even some of the discussion will start entering into the picture more about renewables and energy storage. So that's a far-flung image of what we're seeing some of the discussions occurring. But some of the things that we can specifically talk about is some of the discussions that are happening now in relation to the 2021 IECC. Specifically, in last December, there was a vote that identified that the 2021 IECC should be 10% better than current IECC. So it should take a 10% drop from the 2018. Now, some of the ways that they're identifying that could potentially be used to meet this is requiring the air leakage testing, that blower door, on all buildings. So not just the residential buildings anymore, but also on commercial buildings, whether it be, the high-rise multifamily or even just your office buildings. Another one of the things that they're discussing is having envelope commissioning. If you saw back before, we were looking at more the energy using systems more than anything else, but now they're saying that it will be a mandate potentially for envelope commissioning. Another item that's been identified is something that's currently within the ASHRAE 90.1 code, which is controlled receptacles for 50% of your receptacles. Now, you see the image on the screen where we have a permanently marked fixture that says that this, both of these plugins can be tied to a switch or to a time switch controller so that they can be automatically turned off. Other plugins that we see have only one of the two outlets being controlled and the other one always hot. Where this could be of an advantage is, say, with your computer, where maybe you need your computer tower always powered, but your monitor can be in the automatic switch off receptacle. All right, so for our ventilation and for the rest of the discussion, we'll turn things over to Ben Weissman, who is a principal with our firm in regards to our MEP team. Take it away, Ben.
Thank you, James. Welcome, everybody, and thank you for allowing me to present to you today. I was asked to cover a little bit on ventilation, primarily mechanical ventilation, where it's required, some of the impacts and considerations that it has when we think of it with in relation to the multifamily world. So just a little history lesson. The mechanical ventilation starting to become required and become in our lexicon more with the 2012 International Mechanical Code. Between its reference in the IMC and back to a testing standard in the residential energy code, it was starting to require that projects 3-story and less required mechanical ventilation in the dwelling units, and that was new and started to become a little difficult when that was a burden on developments when, obviously mechanical ventilation starts costing money depending on how you design it. So early on, there were some real easy methods for mechanically ventilating. Let's just bring an outside air duct and call it good. And then code evolves a little bit. 2015, more or less codified that 3-story and less much better, much more directly and clearly in section 403, where it more or less says straight out 3-story and less projects of an R occupancy must have mechanical ventilation. 2018 goes on and says the same. And James was mentioning what 2021 has in store. They fiddled with the language a little bit in 2021 IMC, where the way it reads, it doesn't matter what the testing standard is, if it's residential or commercial, it applies to all building types. So we're going to see mandated mechanical ventilation for all dwelling units, all building types in the 2021 code. Those of you that might work in areas that are under UMC for a while now, I don't recall the exact years, but the way UMC is written a little bit, the only way you can use natural ventilation versus mechanical ventilation is permanent openings. So no one builds a permanently open window or anything into an apartment. So once more or less the way that code is written, if you're under the UMC requirements, mechanical ventilation has already been required for you. So those are markets such as Houston and Austin. So let's talk a little bit about how much outside air, how do we control it? Again, that's an evolution as well. 2015 added some great language and much more clear direction about how much outside air has to come into the unit. It's based on the area of the dwelling unit. It's based on how many bedrooms. And also clarified the controllability. Before 2015, the way the mechanical ventilation code was written, it was that ventilation had to be delivered continuously whenever the unit was occupied. And so that was a little weird. But luckily, since it was a new code and code inspectors don't keep up with new code too often, I think the industry was dodging bullets for quite some time. And luckily, I think we've caught up now, not only in our design, but also just, I'll say, industry knowledge and awareness. So 2015 clarified that you can control the mechanical ventilation system intermittently. And that more or less aligns with the ventilation strategies for that are outlined in ASHRAE 62.2, which is the ventilation strategies for residential projects. James, can you flip to the next? Great. So as I said, when industry awareness, professional know-how advances, we learn some things, what works, what doesn't work. And there's, in the engineering world, there's a lot of different ways to skin that cat. And there's some cheap design methods, and there's some more robust or enhanced design methods. As you can imagine, cheap methods don't cost too much. Better, more robust design costs more money, but you get a better performance out of it. And I'll run down that real quick. And something for builders to be very aware of and want to discuss with the engineers and their clients, and make sure that everybody understands what you're giving up performance-wise, code-wise, possibly, and risk-wise, if you're not willing to spend the money to do something that, in Jordan and Skala's opinion, to do something correctly. So cheap methods, I mentioned earlier, back when mechanical ventilation was starting to come in, and we had done this as well, just bring in an outside air duct, take it to a wall cap, stub it into the HVAC closet, call it good. Well, depending on how that system is balanced, the fan motor itself, and how that outside air is controlled, you might be in violation of the energy code. Back in the day, there wasn't such thing as the energy code police out there. But with more and more awareness and green programs, I'm starting to think that there might be. So something you don't want to get caught holding the bag with, especially if you're building this for someone who's going to sell the building later. They come through and get commissioned and they realize that the building doesn't meet code. That could seriously hinder a building purchase. Controls. When you're just doing that stub duct, the only control you have for the ventilation system now is the on-off control at the air handler. You're at the mercy of the tenant understanding what proper outdoor temperatures and humidity conditions might be in order to run their ventilation system and not cause a problem indoors. You're at their mercy if they just leave the fan in the on position and walk away. You're at the mercy of building operations. If your non-occupied units aren't set in the right position, what could happen to the space in the dwelling units? Code requires a minimum guaranteed runtime, and with just the on-off control, again, you do not have that guaranteed minimum runtime when the spaces are occupied. And again, that could all lead to larger issues of indoor moisture and mold claims that have been known to happen, especially in humid climates. So Jordan and Skala likes to take approach, I'll call it an enhanced design. We there are several manufacturers out there, but we will specify a controls setup that monitors outdoor temperatures and humidities. We have that interlocked to control an intake inline fan. That fan guarantees us, is balanced to guarantee us how much outside air is actually coming into the system, so we know that we are meeting code. And the controls, again, monitor runtime, outside air temperatures, humidity, and keep us safe to make sure that the ventilation system is not running when it shouldn't be. It's not running in adverse outdoor air conditions, yet it's also meeting the minimum run times and allowing us to meet energy code. James, one last one. There we go. So some of the benefits to mechanical ventilation, I think James alluded to it earlier. With tighter buildings, we have these pressure testing, blower door testing. In the commercial codes, it's better materials, better means and methods. We're finding that tighter buildings don't breathe as well as they used to, so we are becoming more dependent on mechanical ventilation. It's kind of the chicken and egg. You know, we want a more efficient, tighter building. Now we have to spend money and energy in bringing in ventilation that was once leaking through the inefficient envelope. But that's where we are. So we're getting better indoor air quality inside, better dilution, less VOCs. The intermittent control, depending on the system design, can give you some better positive pressurization, can help mitigate against unintended backdrafting through your exhaust duct systems, which are often uninsulated, and depending on climate and time of year, you could run into condensation issues. We've seen that happen. And if you want to go, the gold standard of design, which we call it, is your 100% outside air system, which is specifically designed to condition 100% outside air, fully dehumidifies it, brings it down to temperature, and introduces that to your building, your dwelling units, continuous pressurization, continuous ventilation. It's a must for us. It's our basis of design for Jordan and Skala in high-rise buildings and humid climates. And we will always want to discuss that with our client, make sure that they understand what they're giving up when they don't use those types of systems and those designs, those enhanced designs. So things to look out for, again, just a little quick recap. If you're doing a residential project, you know that their mechanical ventilation is required. Keep an eye out for the cheap design. A design that can't be balanced, can't be controlled. You might violate code, and you might run into some bigger issues with legal litigation and claims down the road. Also, keep an eye out for uninsulated outside air ductwork. When that outside air has to come in, depending on the time of year, it could be very cold. It could be very hot and humid. Depending on the time of year, that could lead to condensation inside or outside ductwork. That over time leads to physical damage and warranty claims, and you're right back to litigation, moisture, and mold issues. So I don't know if you can see the bottom of James's slide there, but we're looking, bottom line main takeaway from ventilation is provide a robust mechanical ventilation system to avoid code violations and litigation. Spend that money where it needs to be. Spend it on the system correctly. It saves you a lot of headaches later down the road when you're trying to make settlements on claims. Next slide. The time we're in right now, obviously, you can see I'm standing in my house. I'm not in the office. COVID-19 has pushed us all into a different mode of operation, mindsets, and different considerations. If you or your clients want to discuss other options or enhanced options for viral control, air quality control, obviously COVID-19 is in the forefront of everyone's mind. There are different means and methods out there. You probably have heard or maybe familiar with UV light, specifically the C bandwidth UVC light that you can put in your space, you can put in your air handler systems. It has a lot of options. That's been around since forever, battling polio, and it's been around since the 50s. And more recently, hasn't been tested all that well yet, but they're still coming out, and it's showing great signs, is bipolar ionization. That's been in use for healthcare facilities and high-risk facilities for many years. And the testing for that is getting better, and the white papers are starting to come out on that type of system. There's also some plasma systems and some others out there, but the main two out there, UVC and bipolar ionization. And if you feel free to visit our website, I'll plug Jordan and Skala. We have, you can probably just do a word search, and we have issued white papers and have some AIA presentations, some videos that you can log in and check out those materials. Feel free to reach out to us, and we'll be happy to discuss some of those options with you. Next slide. Oh, and that's it. I'll give it back to James, who's on.
There we go. Unmuted. All right, thank you, Ben. Appreciate everybody's time. Certainly we'll open up the floor now to any questions. As a reminder, if you submit your questions through the chat, Erin Bordelon is watching that and can ask us anything that's on your mind.
I haven't seen any questions come through through Q&A, but again, feel free to also include them in the chat. It is an ever-changing landscape of minutia and lots of digging and lots of interpretation. And energy code is, again, as James has already said, is getting more and more stringent. So that's kind of where we come in, and we're happy to help answer questions, you know, have any, just a conversation about something that doesn't seem right. Whether or not we're, you know, involved in the project, please, my information is up on the screen. Feel free to reach out to me anytime.
I thought I saw a question come in, but
are you specifying insulated vent pipes currently?
Yep. You went back to mute, Ben.
Sorry, I was trying to look at the Q&A. Could you repeat that for me, Erin?
Yes, the question is, are you specifying insulated vent pipes currently?
Okay, yeah, great question. So on outside air, we've always been doing that. That's just good best practice. On exhaust systems, depending on the construction type, it's yes or no, and humid and the climate. So many wood frame projects that have their let's say flat roof or floor ceiling assemblies fully blown filled with insulation fill, we're finding that we're not going to insulate that ductwork because by nature of the fill, it's already surrounded by insulation. But if in concrete projects in humid climates, such as Houston, we are now specifying insulated exhaust ductwork, where those duct systems are not within a thermal envelope any longer. They're dropped down, they're in a soffit space perhaps, or exposed depending on the design. And they are much more susceptible to the indoor temperature. And that's that larger delta T, that difference in temperature between the outdoor air conditions and the indoor conditions, is driving more issues with condensation. So again, depending on the climate and construction type, we are specifying insulated exhaust duct systems. Good question.
I have one other question for you. Related to, it kind of tags along with that. One of the issues I've heard from a claims anecdote is condensation forming on an exhaust pipe that looks like a water leak, quote unquote, because water may show up on drywall, but it's not actually an active water leak. It's some form of condensation. Is there a best practice to avoid that situation?
Yeah, again, I think that's, like you said, that's related to insulating that duct system. So if we think that's a climate where we've seen those types of claims been made before, I've seen that in Florida mostly, but slope it. So in addition to insulating the duct, sloping the duct, giving that somewhere for that water to go, sloping the last, I think we put in our specifications, at least sloping the last 15 feet, if possible, of that ductwork to the exterior wall. Installing that vent pipe that with the longitudinal seam, the seam along the length of the duct. Get that seam up on top of the duct, not down. So what that helps with is if there's any condensation within the duct, it doesn't find that long seam and start creating a drip pattern that might look like a pipe leaking all across, all the way down your soffit out along a bedroom wall or something like that. Does that help?
My only other question is something like an April air system. Does that solve that problem, or does that help eliminate it, or there's no guarantees if you do that type of system?
I'd love to give you guarantees. Let's say it helps. The April air system, if installed correctly, it's not just the April air system. The April air system is a controller tied with an intake fan and shut-off controls. If it's not set up correctly, if it's not interlocked to the air handler correctly, so I'd say a properly designed and installed and operating April air system helps provide intermittent pressurization to mitigate against the intermittent exhaust and negative pressurization.
Oh, I think,
He froze. I don't think he's actually injured.
Unit C. So that intermittent start to get into a different issue if you go further. But when you're south, you want to start looking at more continuous ventilation systems.
Yeah, and actually to speak to that, the April air, like Ben was saying, there are lots of there's a sequence of operation that I know Jordan and Skala publishes in their drawings, and it can be different for different engineers, but there's definitely a lot of different equipment that needs to be coordinated and functioning properly for it to actually work as intended. So I've seen the humidity, the outside air temperature wiring just thrown away. It wired incorrectly, completely bypassed the inline fan. So it's just, again, that's also where commissioning comes in and making sure that the systems and the installers are functioning as intended and don't get VE'd throughout the process, pricing process. So, and there's one. Sorry, I was just going to say there was one question about commissioning, about the building envelope commissioning that's in the 2021, if that would be the same qualifications a person that's doing the commissioning currently for the mechanical and electrical systems. James?
Yeah, with it being undecided, not fully in there, they haven't specified too much in regards to, is an actual certification going to be required, which is one of the things that we're seeing more and more popping up in more and more discussions for the compliance pathways. In regards to that ASHRAE 90.1 roadmap, they were talking that the prescriptive pathway is likely to go away at some point. So then how do we ensure that the people doing the energy model is appropriate? So there's more and more discussions about that the people doing the energy code work have very specific certifications and designations. So that's something that we might see in the 2021, that there is an official envelope commissioning certification, since it gets into, it's more of a cross conjunction between air sealing as well as moisture intrusion.
Yeah, and actually the city of Denver just as of August 1st, adopted a new code that classifies all multifamily, 3-story residential, no matter what the height, as commercial, and also requires building envelope commissioning by professional engineer, BPI, or HERS rater. So that's, that is actually happening in a major market. So just something to keep your eyes out for. Okay, I don't think we've got any other questions unless.
I don't see any other questions. If one pops in the next few seconds, we'll let it go. Quickly, while we're waiting to see if any other questions pop up, one, I want to thank Jordan Skala for offering to put on this presentation. I appreciate it. Take this time for the virtual round of applause you would normally hear. And on a personal note, this will be my final meeting in the 2020 year as the chairman of the Multifamily Builders Council. I want to take this time to thank my board members for helping us put on this year and moving to the virtual formats and all the different things we've done. I can't thank them enough for all the work it takes to do this. And at the same time, I want to welcome in our new chairman, who will take his chairmanship late September, and that's Renee Grossman. So I look forward to him being chairman next year. And without any other questions, I don't see any other questions. Erin, do you see?
Nope.
Okay, well, I'm going to conclude our meeting. Again, once again, thank Jordan Skala for helping us out today, and it was very informative. And I'm going to close the meeting, and you guys have a wonderful rest of the week.
Thanks so much for having us.
Thank you.
Thanks.